Hello everyone, this is Mr. Sina once more. You are a renewable energy trainer, and today we are going to uh, look at PV solar orientation and PV solar panel tilting. Yeah, right away, let's go to the whiteboard and okay, let's clean. Now, so our first learning task, first learning task, learning task number one is to determine, the PV panel orientation at any given latitude. Okay, number two will be to determine the optimum tilt angle for PV solar installation. Okay, so right away, the Earth revolves around the sun. Creating seasons. These seasons are due to the tilt angle, of the Earth. Okay, this tilt angle 23.5 degrees is responsible for the different insolation received at various places in the planet Earth. Okay, so this is your sun. Okay, so what happens is if you are in the northern hemisphere, if you are in the northern hemisphere, the amount of rays that will reach this part will be minimal, will be limited, and the south will have more sun rays or sun insolation, since it's closer, because of the tilt angle. Most of these parts will be exposed to the sun's irradiance, okay. The other thing to note is this is the equinox. In the equinox, the all part of the Earth will have equal exposure of sun, will have equal days and equal nights, equal nights. while if you are in the northern hemisphere, during this is December, um, we'll have we'll have longer longer nights and shorter days, and shorter days. Okay. uh, in vice versa, for those who will be in the southern hemisphere, they'll have longer days longer days and shorter nights. Okay. um yes, so that's what happens. Let's proceed. So in order to be able to determine the correct um, orientation, you need to understand the latitude of the site. uh, so number one, determine the latitude 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 uh, latitude of the site by checking on the wall map or using GPS applications available on your Play Store. So number two, after determining the latitude and establishing if you are in the northern hemisphere, southern hemisphere, or at the around the equator, you can go ahead and now let's say you are in the north, assuming you are in the north. Okay, so if you are in the north, let's try and see what will happen the various seasons so that you can determine the tilt. So number two will be to determine the tilt angle. Remember, if you are in the north, if you are in the northern hemisphere, um, place your panels to face south, and we are going to see in a small while why that is true. So what the same time, if you are in the southern hemisphere, place your panels facing north. Okay, so this is your west, this is your east, this is your north, and this is your south. Okay, so let's follow the sun. During winter, the sun will rise. Remember, we are working on the northern hemisphere. So during winter, the sun will rise southeast and set at southwest. It will rise at the farthest, and the sun will be lowest and farthest. So that if you have your project here, This is your project. Okay, this is your project. So the distance between where you'll be standing and the sun will be very far, and the sun will be at its lowest point. Okay, we call this angle, this angle, this angle, uh, this angle, this angle, we'll call it altitude, altitude, while this angle um, from the north, this angle, okay, this angle will, is the azimuth, azimuth, azimuth angle, which for this case we are giving it 180 degrees at noon. At noon. Okay, so at equinox, the sun will rise at east, rise at an angle, at an altitude angle of around an altitude of equinox, at equinox, altitude angle, let's give it 45 degrees. Okay, these are the one angle, altitude, 23 degrees. So during summer, the sun will rise northeast, go high to the south, set somewhere in the northwest. Okay, so the best angle to orient your panel is towards the south. Okay, towards the south. Okay, and in order to be able to maximize the energy, remember, as the day progresses, okay, as the day progresses, the sun rises in the morning. Okay, so this will form what we call the solar window. The solar window. Okay, between this time and this time during the equinox, this is somewhere between 9 to 3:00 p.m. Okay, and this is where you want to maximize your solar energy collection. So for this case, in the northern hemisphere, you orient it to the south, and then you tilt it. If you want to maximize your energy during the winter, you add 15 degrees plus, let's say the latitude of the place is maybe, let's say 30 degrees, so it will be 15 plus 30 degrees, which will be 45 degrees. During the equinox, if you want to maximize your solar energy, you just set it at 15 degrees. If you want to maximize it during the winter, you can give the panels 30 degrees minus 15 degrees, which is 15 degrees. So you can see the best position would be 15 degrees. You will be able to to still get your maximum solar during the summer, during the equinox. And yeah, okay, so let's proceed to the south. This is what will happen in the south. Okay, you are the southern hemisphere. Let's say you're in Australia. You're installing solar panels. Okay. Okay, this is your north, your south, it's your west, this is your east. Okay, the sun will rise northeast. Oh, we're in the southern hemisphere, southern hemisphere. Okay. Then during equinox, rise east, set at west. Okay, it's your west. Then during summer, it will rise at southeast and then rise all the way towards the south, then set at okay, it will rise at southeast, rise all the way towards the south, then it's an angle over an altitude of around 66 degrees. So the best place, now let's see if you have your project here. Project here. You have your project here. Okay, that's your project. So the best orientation, as you can see from this representation, is to put your panels facing north. Okay, make it face north for maximum radiance. Okay, now how do you determine the tilt angle? The tilt angle is if you are say at 40 degrees south, if you want to maximize in the winter, it's 40 degrees plus 15 degrees, which is 55 degrees. So this is how you're setting panels. This is how you set your panels. It's 55. Altitude will be 55. Okay, and you set your panels like this. Okay, and there you go. Now let's move to the equator. If you are stationed at the equator, this is how the sun will behave. Okay, so this is your west, this is your east, this is your north, this is your south. Okay, so what will happen is the sun would rise here, the east, southeast, and it will set in the southwest. Okay, during the equinox, the sun will rise from east and set directly to the west. Okay, during summer, uh, that's summer in the north. The sun in the equator will rise northeast and set down in the northwest. So as you can see, you can set your panels. Um, you can set your panels either facing comfortably, either facing south or facing east. Okay, so if you set it at 0 degrees plus 15 degrees, okay, so let's say you have your project here. It's your project. This is your project. Okay, this is your project. Okay, so you if you give it an angle, if you can either put them here or put them here. Now it will be dependent on which season do you want to maximize. At which season do you want to maximize the solar energy? For pumping, maybe you want to maximize during summer. Okay, so if you want to maximize during summer, that's summer in the north. Okay, so if it's summer in the north, not summer, it's when it's winter in the north, you will want it to face south. Okay, and for our case, let's say here in Kenya, it's dry between maybe November to February. That's when it's winter in the north. Okay, so you would want to place your panels this way. If it's for lighting, for example, you want to harvest more during when it's summer in the north. Okay, that's in the month of July. You need maximum solar energy, so you place your panels. I would prefer to place my panels in the north. If I'm placing it for lighting, if it's lighting systems, but if it's for solar pumping, I'll put it in the south facing. I'll put it side facing. Okay, so that marks the end of my presentation. It marks the end of my presentation. See you next time for another tutorial. We'll do IV curve chart to we'll study the IV curve to understand characteristics of solar panels. Thank you so much.